Okay, hello, we are back and we are on Article 230.26 and it's called point of attachment. Okay, and so go ahead and get to 230.26. There again, I don't usually tell page numbers, not always at least, sometimes I do, but I think you need to learn the codes because the 2020 is coming out, all the page numbers are going to change anyway, right? So go ahead and look that up. And there we go. Okay, so let's go ahead and get started on this. 230.26, point of attachment. It says, the point of attachment of the overhead service conductors to a building or other structure shall provide the minimum clearance as specified in 230.9 and 230.24. In no case shall this point of attachment be less than 10 feet above finished grade. Finished grade means from the ground up. If they put tile down, if they put pavers down, if there's grass, whatever that is, to the point of attachment. The point of attachment is where that support is so that messenger line can attach to it. There's that point of attachment. Right now I have a broken line here to show you that there's distance here. Obviously this is not, 10 feet. Obviously this is, it's not to scale, right? So don't freak out, but it's the point of attachment. If that's on the side of a building or if it's on the mast, wherever that support is, that point of attachment, that must be 10 feet from finished grade regardless. It could be taller, right? But it can't be smaller than 10 feet. Okay, then it goes on to 27, 230.27, means of attachment. The way we're going to attach it. It says, multi-conductor cables used for overhead service conductors shall be attached to buildings or other structures by fittings intended for use with service conductors. Open conductors shall be attached to fittings identified for use with service conductors or to non-combustible, non-absorbent insulators securely attached to the building or other structure. Remember, this is our insulator support. Now, this is made of metal and porcelain. Porcelain is non-combustible. Metal is considered non-combustible. Porcelain is non-absorbent. Porcelain is an insulator. It's basically glass. Glass is one of our best insulators. There is no such thing as a true insulator. We'll get into that when we get into 250, but just understand. An insulator is only as good as the voltage rating that's given for it. That's why you always need to look on your tools, see what the voltage rating of your tools are, or something like that, right? If it doesn't have a voltage rating, assume nothing. If it says like 1,000 volts, don't try to use it on a 2,300 volt system. Okay? It is what it is. Okay. So point of attachment and it has to be non-absorbent and stuff. Then it says service mast as support, and that's exactly what we're doing here. We're using the service mast as support, right? So now it's talking about what if we use a service mast as support, okay? It says, only power service drop or overhead service conductors shall be permitted to be attached to a service mast. Did you get that? Only service drops or overhead service conductors. No cable TV, no satellite dish, none of that stuff belongs on our riser or our mast. You see it on there, take it off. It's a code violation, right? Tell your customer, I'm sorry, that's not allowed to be on there. If it causes a problem and a fire, their insurance is not going to cover it. The homeowner insurance will take one look at that and say, I'm sorry, right? Service mast used for the support of service drop or overhead service conductors shall be installed in accordance with 28A or 28B. And when you flip over and you look at 28A, it says strength, right? What are we talking about the strength? It said the service mast shall be of adequate strength or be supported by braces or guys to withstand safely the strain imposed by the service drop or overhead service conductors. If you look at this, you've got wires coming down here, right? I didn't even draw them all in. Let's assume we got the rest of them in, right? Boom. Boom, right? These all have weight on them. Okay? These all have weight on them. And they're going to pull against this pipe here. And I showed a brake, but obviously if it was a real pipe, there would be no brake. The brake just shows you that it's really more than, that tall. But let's assume it's solid, right? Boom. And it says it has to have proper strength. This is why most cities will not let you use EMT or other things unless it's super, super supported. Most of them, especially on residential and light commercial, will tell you you're going to use rigid pipe, right? Rigid pipe. For your conductors going all the way up, you're going to use rigid pipe, okay? But they say, oh, if that's not good enough, let's imagine we had a roof here, right? Let's imagine, boom, boom. Here's our rooftop, right? Here's our mast coming up through our rooftop, right? Now, if there's too much strain this way, it says to put guy wires. Now, I kind of drew a crooked. Let's assume this isn't here, right? And let's assume the mast is coming down on our building. Let's assume this is a building here, right? And it's coming down to a meter, kind of weird drawing, right? But this is really our building, right? And here's the rooftop, right? And the weight strain is going that way. So I'm either going to have some type of brace, right? Or I'm going to put guys, and guys are like wires that come down, right? And they create this like triangle. So because the triangle is really strong, right? So it's like this, right? And the guy wires are keeping that pipe from being pulled that way. And because they're going in two directions like that down to the rooftop, it keeps it centered as it wants to try to pull that way, and it supports it. So we have to have those in place if our mast or riser is made out of material that's not really thick and strong, or if we went up really high too, right? Because remember, 8 feet above a normal roof, and then we had all those exceptions why we can go smaller and smaller, right? So just remember that. If you're going 8 feet up on a mast, you are going to have braces or guides. That's just all there is to it, right? Okay, it says hubs must be intended for use with the conduit that serves as a service mast. Remember I said there are hubs that are not rated for service masts, right? So you got to make sure you use the right hub. Otherwise, it's just going to break off right there, right? And you don't want to use the wrong hub. Okay, then it says B, attachment. Remember we have to follow both A and B. Attachment, service drop or overhead service conductor shall not be attached to a service mast between a weatherhead or the end of the conduit and a coupling where the coupling is located above the last point of securement to the building or other structure, or is located above the building or other structure. So this is what they're talking about. So here's our building again, right? Now sometimes you have really tall buildings, okay? And this mast, a 10-foot piece of pipe doesn't do it. Sometimes you need a longer piece of pipe to get from your meter up to your roof and above where you need to be, right? And in the case that you need a longer one, you're going to have to do something about that, right? Let me just clean this up a little bit here. So what are we going to do with that? Well, we're going to have to put a coupler somewhere if it's too long, right? So what the code is saying at this point here is where can you put that coupler, right? So imagine if I put a coupler here because my pipe was, right, my pipe was 2, so I have a coupler here, right? So that means this pipe is threaded halfway into the middle here, boom, halfway. Then it's threaded halfway here. Do you think that's a really strong point? That's actually a really, really, really weak point. Really weak point. So the code says you can't do this. That coupler cannot be above the highest point of support on the building. Right? So some cities actually will say, hey, the first 10 feet from the weatherhead down must be a solid piece of rigid pipe. One city I worked in said the first 20 feet. And I'm like, where do I find a 20-foot stick of rigid pipe? And I'm thinking how heavy that thing's got to be, right? Because this was an industrial building. And they said, here's a list of places we know that carry them. Pick one, right? But this would be a violation. If this is my rooftop here, right? Here's my rooftop. This is a violation because it's above the last point of support. If I'm going to have a coupling, right, it's going to have to be below the last point of support, right? Now I know this isn't drawn to scale, right? But if I'm going to have a coupling, it's got to be below the highest point of support. Okay? That's what it's talking about. Okay. Then it says supports over buildings, and it says service conductors passing over a roof shall be securely supported by substantial structures. Where practical, such supports shall be independent of the building. Imagine that, right? So we try to avoid going over buildings all day long. It's just super, super costly. You don't do it unless it's absolutely, absolutely the only way, right? And even then, you probably think twice, 3 times, 10 times about trying to attempt it. Okay, this brings us to 230.30. Underground service conductor. So we're now talking coming in laterally. Laterally means underground and up. So we would be below the earth, right? And we'd be coming up into the panel. This is what they're talking about. And actually, we'd be much lower than that. Okay? But we're coming in up underneath the earth here, right? We're no longer doing this overhead thing, right? This is gone. We're no longer doing the overhead thing. It is gone. Okay? All gone. Don't think overhead now. We're thinking underground. What the heck? Did I use the wrong pen? Give me a moment. Let me see if this comes off. Oh yeah, I just got to rub hard. It's a new pen and it's a weird company and it just doesn't come off as nice as the other pen did. Okay. Just got to scrub. Wow. That's some tough stuff. Okay, so we're coming up underground, right? And so here's what it says for underground. It says insulation. Now remember before we said, hey, all the conductors have to be insulated, but then there was the exception. The grounded conductor could be bare, right, if it needed to be. And there's 4 reasons why it can be bare. Bare can be used in a raceway, bare copper for direct burial, bare copper for direct burial without regard to soil conditions, or aluminum copper clad as long as it's protected against the environment. And then it says wiring methods. B, underground service conductors shall be installed in accordance with the applicable requirements of the code covering the type of wiring method used and shall be limited to the following: RMC, rigid metal conduit; IMC, intermediate metal conduit; let's see, where's PVC, RTRC, which is a resin thermal, I can't remember the last word, right? And you have a little list there of what you can use, right? And then it says 230.31, size and rating. So what's the size? Well, there again, it's just like above ground. Above ground, remember, overhead, minimum 8 copper, 6 aluminum, right? And then you have that one exception where if you had a single circuit, you going down, and you're right, you could have a number 12. If you had one of those weird little services I told you about, like around railroad tracks or for seismic little houses that detect seismic activity out in the deserts and along fault lines and stuff like that. Okay. And then the grounded conductor, again, it tells you again 250.24, and we went there, and remember, it took us, after we played hopscotch through a few things, to table 250.102C1. So here again, you should write under 230.31C, you should write underneath where it says 250.24C, you should write 250.102C1. That is 250.102C1. Okay, table. That's where you really get the size for the grounded conductor. And I don't want, if you get a question like that, I don't want you to tell me 250.24. That's not where it is. That just tells you to go someplace else. So one way I'm going to know if you watch this is if you made that note in your book. If you don't make that note in your book, I know you didn't watch this with your book available. Okay? And hey, I'm sorry, you deserve to get it wrong on the test. Okay? I told you, you need to learn this stuff. It's really, really important that you get it right. Okay, that brings us to 230.32, protection against damage. Now remember, we're still talking about underground service conductors, right? So if it's something that the utility company provides, that's a service lateral. If it's something that we provide for our customer or the customer provides, that is an underground service conductor. Remember, service conductors are ours. Service drops and service laterals belong to the utility company. Okay, so once again, underground, what's it say? It says, hey, we're going to follow 300.5. What's 300.5 say? Well, you should have had it in code A, but to refresh your memory, let's go ahead and write it down here, hopefully so you can see it. And there we go. I was grabbing the wrong rag. So, really quickly, 300.5. Now, I call it the CPR of burial. Okay, the CPR of burial. Now, when I show you this, we're talking the general rule. Okay, not under concrete. General rule, not under concrete. If I want you to think of it as being under concrete, I'm going to say, hey, under concrete. Okay, because under concrete, you can shorten the distance a little bit, the depth a little bit, I mean. I'm talking generally, okay? And just remember, unless I tell you under concrete, you don't assume it's under concrete, because we can have all sorts of different rules. I can be under a runway and it'd be different. Okay? So, let's look at this for a minute. Here's the CPR. In fact, I'm going to stand over here. Hopefully I can write backwards. C. Can you see the C? Boy, that is really light. This pen is dying. Let's try that with a different pen. Okay. Let's see. Maybe this pen will be better. C, P, and R. Okay, the CPR of burial, as I like to call it. C stands for cable. P stands for PVC pipe. And R stands for rigid metal pipe. Okay, the CPR. This is 300.5. Cable. So like underground service entrance cable, it's going to be buried to 24 inches. Not counting if there's concrete over there, right? General rule. And that's measured off the top of the highest cable. So from here to here is 24 inches. PVC is 18 inches. And that's above the highest conduit. And we might stack them. We do that all the time. I've stacked them 3 high. 5-inch round conduits, 3 high. That's 15 inches with an inch in between each one, with 2 inches of base underneath them, right? You do the math. That's going to be 17, 18, 19 inches plus 18 inches. That's how deep that would have to be. The rule is from the highest or the top of the highest pipe cable, right? Same thing with rigid, but rigid, solid rigid metal is only 6 inches. There again, from the highest pipe up. Okay, now, just my weirdness because I like math and stuff. Watch this, 24 minus 18 will equal 6. I did that to kind of remember these 3 in my head. 24 minus 18 equals 6, right? So if you forget one, it's CPR, like you're bringing it to life, you know, CPR. We got to do it right or we're going to kill things, right? CPR, done right. Okay, that is the direct burial, CPR 300.5. For underground service cable, we are talking 24 inches. Okay, 24 inches. Okay, so, let's see. Let's drop down to service entrance conductors. Okay, service entrance conductors. 230.40, number of service entrance conductors. And it talks about the different numbers, and it says right here, each service drop, set of overhead service conductors, set of underground service conductors, or service lateral shall supply only one set of service entrance conductors. Okay, only one set. And then all you see the rest is exceptions, right? There's so many exceptions missed. So we have this service drop coming down, right? And it's supposed to only go to one set of service entrance conductors, but now it's going to this one, and it's going over to this one, and you're like, wait, I thought it only said one. Yeah, well, look at all the exceptions of this, and I'm not going to read through them all. We're just going to kind of skim through what they say. A building with more than one occupancy. There you go, right? We got multiple occupancies. They can't all be serviced by one drop, maybe length of the building, whatever, right? Okay, we're now going to have the one drop, but we're going to have break-offs going to, right, to different sets. Okay, how about number 2, where 2 to 6 service disconnecting means in separate enclosures are grouped at one location and supply separate loads from one service drop set of overhead service conductors. One set of service entrance conductors shall be permitted to supply each or several such service equipment enclosures. Right? So there again, you might have one drop, but you might have 4 different service enclosures. Boom, boom, boom. And you're going to like splinter off of that one, right? Like go off of that one. Right? You'll see that if you drive around. You guys, now that you're starting to get into this, you should be looking at services, power poles, stuff like that as you drive around, so you can get an idea of how things are really put together, right? I can only tell you so much, draw so much, but you really need to see it, right? So don't be afraid to get out there and look. Okay, and you know what? We're gonna, let's see, service and, yeah, trying to see if I want to stop there or move on. We're at, trying to see where a good spot would be. Probably shouldn't have started service entrance conductors. Okay, doesn't matter. We'll just stop here and pick it up at 2:30:41.